Awesome. Well, hey everyone, glad to be a part of the first ISG meeting back in person. I know we presented virtual. Before we go too far, if anyone wants to let us know that you're here, you can grab that QR code, give us your name and email, and we'll let you know about anything PWC related. We've got lots of jobs open this summer, so go ahead and grab that. But after that, I'll go ahead and introduce myself. I'm Brian Gillenwater. I'm a manager out of our PWC Minneapolis office. I graduated in 2016, which is a long time ago now, but I've probably had class in this room. And yeah, I'm one of the managers on our cyber penetration testing team, so we do all sorts of different types of penetration testing, red teaming, and offensive security for PWC. And I'll let Paul introduce himself as well.
Yeah, I'm Paul Chihawk. I'm also on the cyber penetration testing team. I graduated a couple years ago out of Iowa State, software engineering. I do a lot of red teaming, a lot of application security, some purple teaming, pretty much anything security.
Awesome. Yeah, we've got a couple of just intro slides, but we've actually got some cool technical concepts that we've used on our engagements to talk through. Don't want to bore you guys with the HR recruiting stuff. If you do want to learn more about PWC, we have an info session right after this in Carver, I believe, so we'll have that detail, but we're actually going to get into some topics here. So if you guys have questions or whatever, feel free to raise your hand or just shout out questions, grab more pizza, whatever you want. Maybe a little bit about PWC and where our team sits into it. We sit in what's called cyber risk and regulatory. There's a whole bunch of different parts of that, but the ones that you might be a little bit more interested in, strategy, risk, and compliance. This is thinking about how we take things like regulations or kind of like where we're taking our business, what's our strategy for dealing with cyber threats, and building those roadmaps or doing those assessments. Implementation operations, which is by far the kind of most technical part of cyber. So that's where customers that are looking at security and any cloud vendor really, or coming in, grab some pizza. Cyber defense, that's where we sit, vuln management, security architecture, dealing with incidents, all that kind of good stuff. And then identity access management, who has access to what, and when should they have that access. And finally, information governance and privacy. This is where you think about things like GDPR or the other privacy regulations and how a business may respond to those. For those who just joined, there's pizza up front. Feel free to come grab it. Hopefully there's enough chairs for everyone. More specifically, Paul, you want to talk about what CBD Squared is?
Yeah, so we kind of have a whole slew of offerings that we go through. I'd say our more standard would be more like just a standard network penetration test. In the olden days, we'd actually go to a client on site. Now we just ship them a laptop, have them plug it in, let us on their network. But we'll either ship them a laptop, travel out there, we plug into the network, and then from there on, we are an attacker with access to your network. What are you going to do? So we do some layer 2 style of attacks, try to gain like initial access, and then keep moving laterally throughout the network, escalate our privileges, gain access to whatever their crown jewels are, be that credit card data, PCI, anything really, HIPAA, all the sensitive data, and then sometimes DA is the goal. Personally, DA is always the goal. And then from there, you kind of have God privileges in the network most of the time. We also have more red teaming. That's like I am an APT group. I'm no access given. I'm getting in through phishing or breaking in like a website or whatever. Maybe they expose like AWS credentials in a bit bucket that's public or public S3 bucket. It could be a lot of different things, but this is no help from the client. We want you to gain access to X. Have fun. Do what you got to do. Don't bring anything down. And then some of the more like wireless and physical, that's generally on site. We're looking at their wireless infrastructure, their Wi-Fi, the actual physical breaking into buildings. Purple teaming, way more coordinated, sitting down with the blue team, helping, we'll execute an attack, go back with them, sit in meetings. Here's what we did. Here's how you can detect it. Do you have any visibility into this? No. Okay, here's how you can gain some insight into what we're doing. And then application, I've done a whole lot of this. It's mostly web applications, desktop applications, kind of whatever. It's a lot of like your OWASP top 10, going through, checking for any findings you can have. These are, a lot of companies want these just because everyone has public, external facing applications. Everyone's got at least a website. So very common to have a application test. Scenario-based assessment's more just like, they pick a scenario and you move on with.
Cool scenario would be like lots of ransomware. So it's, can you get into our backup systems or architecture? Can you delete our backups? That's the question that's asked.
Or it's like, okay, you hacked a web server. What can you do with that? You're on a server subnet. Maybe they just give us a web server that has a web shell on it. How can you move from there? And then cloud assessment and IoTs, those are kind of more specific to whatever the environment's going to be. Obviously, cloud is your AWS, GCPs, DigitalOceans. You have usually CLI access, looking at configurations, trying to figure out what's misconfigured, how an attacker could potentially abuse that.
Yeah, a couple other things just to highlight for you guys. So members of our cyber penetration testing team, we do sponsor like certifications. So if you want to get something like your OSCP or OSWE, that's something that PWC does sponsor our associates to do, or go to specialized stands training for those various topics. Say something like, an IoT assessment that's not kind of general knowledge. You may need a little bit extra there. So we help with that. We've also got our own training courses we run everyone through. So kind of bringing you up to speed with the types of attacks we do, along with we have our own set of tooling and our own lab environment. We call it the Red Lab, that we can actually test attacks and stuff against like a full simulated enterprise network prior to going and doing it on our clients' networks. So maybe just to walk you guys what a typical kind of test might look like, we'll just kind of briefly touch on this one. So say this is like a red team or something where you're starting from the outside. So the first thing you do is you're looking for systems and or people to take advantage of. So when we think about systems, it's what's hosted on the company's external network, what's their public website, do they have presence in the cloud? Sometimes that's a little bit tricky to find, but you can do stuff like, say, look at certificate transparency logs to figure out what servers have requested SSL certs associated to their domain name.
Something fun we've been doing with that recently is there's a service called Grey Hat Warfare, which indexes public S3 buckets in Azure storage blobs and also enumerates all of the like bit.ly shortener URLs. And then they index all of them and you can search that. So you can actually find a lot of really cool stuff just by like searching their index. And the free version of that gives you like 20,000 some searches over a subset of their buckets, but it's a pretty fun one.
And then we start thinking about initial access. So say we dug through LinkedIn, we found somebody who looks like they may be a good target. We found something unique about them. Maybe that helps us target that spear phishing email a little bit better than a generic phishing campaign. And maybe we're asking for usernames and passwords, but a lot more, it's usually sending them some sort of malware, a malicious Word document, a calendar invite saying that, hey, IT's found something wrong with your computer. We'd like to do some updates for you. Whatever it may be, our goal is to get that malware on their system and get that initial access inside the network. And then we start looking at lateral movement and credential access. This is something that kind of goes in a cycle. So moving from the system that you initially compromised to try to get into other systems to get additional elevated credentials. Just trying to steal credentials. And we're going to talk about that one a little bit later here. And then finally, finding that sensitive information. And it may be different based on the company. So think about maybe a retailer, they care about the credit cards they've taken at their stores. But if you think about a hospital, it's the medical records that are stored from their patients. So knowing what those crown jewels are and where you want to be going, and a lot of times it's just finding them is the hard part. So that's kind of what a typical project might look like. Obviously, with all those different types of things we do for our clients. There's some seats in the back, I think, and then there's also still pizza up here for anyone who walked in. So before we talk about our first attack that we've used, does anyone have kind of questions about our team or PWC or anything like that?
So I was kind of curious, do you ever try to do like exfiltration of like whatever data you find?
Yes.
We do. I'd say that's pretty common. Once we do get access, is we'll create some mock data, and then we'll exfiltrate that, because we don't really want to start stealing their actual data, because then that puts us at risk of what if that system, got compromised or something like that. But yeah, generally when we find sensitive data, we'll make a mock of it, just generate a whole bunch of fake data, and then exfiltrate that. Honestly, 99% of the time, you just HTTPS web upload, no one sees it. So,
or you can just base 64 encode it, and
Yeah.
almost anything that's watching even clear text is like, I don't know what that is.
yeah.
So it's surprising when you look at like network exfiltration how easy it is to do. A lot of times it's just the raw amount of data uploaded is what will get you caught in most networks.
Mm-hmm.
So you don't ever do like large amounts of data uploading?
Every once in a while. I think we had a client once that wanted like a terabyte uploaded, and we're like,
Yeah.
well, we have a 100 meg internet pipe on this system, and we have this
Yeah.
much time. So I think we wrote a script that just was setting the same data set and then deleting it once it was uploaded, so we didn't have to like get a hard drive for the system. But yeah, we've done all sorts of crazy things, especially those like simulations or purple teams. They'll get some of those kind of more interesting requests of what about X, what about Y style things. So
Slack. I assume all of you have probably used Slack. Slack is great, awesome chat application. It does have a couple downsides though that are really handy for abusing. So once you have access to someone's computer, as of 2 months ago, this worked. And we'll get into that in a little bit. But what you could do is there's this really cool cookies database file on your computer. And that database just lets you impersonate any user that is signed in. So if I get access to someone's account, or I have admin on a computer that has shared accounts, I could just go snag this cookies file and then pull out the cookie and sign into the web browser as that user. And then I could impersonate them, search for SSH keys, passwords, start sending more social engineering payloads. No one questions malware when it comes from someone that they know, So Slack is really, really useful. Was a tool, Slack Pirate, and that would just automatically use the Slack API to search for a bunch of stuff. It's currently broken because Slack totally changed the way their API worked. And the really cool thing about this is it bypasses MFA, because you have a valid cookie. You're not trying to sign in with username, password. You just have a session. You're good to go. So the SpectreOps blog that I originally learned about this from is there, has some more information, really handy. But recently, you can go to the next slide. Oh yeah, actually, this is just some examples of it. It was literally just a SQL-like database, plain text cookie. You could snag it, and then, yeah.
So does this still work, you said?
No. Due to the EA hack, Slack decided that they should probably change some things. So now they use the data protection API, and I should say, this is only on Windows. If you have a Mac, it's all still plain text. You're good to go. So data protection API sounds way better. It's really not. Most of the time when I was getting access to these Slack cookies, I was running as that user. So I sent them a malicious Word document. They downloaded it, enabled macros. I had a session on their system. So the reason data protection API doesn't really help that much, even though it looks really encrypted and super secure, is that if I'm already running as your user, I can just download some code, execute it, and then it'll call the DP API and say, hey, I am this user, please decrypt this for me. And it is more than happy to do that for you. So it does put a little hindrance on you. If, let's say I fish one user and they have a domain admin who also has an account with a Slack cookie. Well, now I can't access that domain admin's cookie. So you either need administrative access to the system or to be running in that user's context. So it does hamper you a little bit, but as an attacker, most of the time it's not a big deal. And there's a bunch of examples online. This is something that I kind of just wrote, so I don't really have great examples to show you with screenshots, unfortunately. but DPAPI is very well documented, and Mimikatz is a tool we'll be talking about a little bit later, but they actually have functionality built in to query DPAPI. So theirs is specifically geared towards Chrome and stealing Chrome cookies, but it's the exact same process for Mimikatz, or for Slack.
Probably something I should say before we go any further. Test this on systems that you are authorized to perform penetration testing against. I'll just leave it there. Yeah, do you want to talk about the EA hack a bit? I don't know if you mentioned that or not.
About the what?
The EA hack, how it was...
Yeah, so we're kind of guessing as to why they changed this, but I'm assuming it's probably not a coincidence that this change happened very closely after the EA hack happened. But if you guys aren't aware, EA got hacked pretty recently, and a whole bunch of compressed data got stolen out of there. It was like source code for some video games, not sure which ones. You could probably find them online. But the hackers attempted to extort EA, and EA just said, "No, we don't care, release it online." So it's out there somewhere. But the problem with this is that those Slack cookies, they were able to buy them for like $8 or $10. Like they were just dirt cheap, bought them online, and then they used them to sign into the EA Slack workspace. So
Yeah, 'cause
they're
you
pretty
usually-
powerful cookies. If you do get them stolen or compromised somewhere, they last forever, or a very long time. I guess I don't know if it's still forever. I haven't really tested that yet since the change, but from what I've seen, those cookies persist basically forever, which makes sense if you think about it, because when you have the Slack desktop client, you don't sign in every time you open it. You sign in once, and then whenever you open it, it just works. So they either would have to make you sign in consistently or accept some additional security risk. Yeah.
Just for the desktop Slack.
Well, the web Slack also has cookies, but those are a little harder to compromise because you have browser protections in place. If you have access to someone's device, you can steal their Chrome cookies, but this would be more specific to the desktop because this is just a SQLite database on your desktop. They also modified the way their API works, so the automated tooling's currently broken. It still uses cookies, so if you want to help out the open source community and go submit a pull request, I know I'd appreciate it.
So the second thing I want to talk through, and probably the cooler one in my opinion, Slack is fun, but this one is our like bread and butter.
Mm-hmm.
Who here knows what LSAS is? One? Anyone else? I'll give you a hint, it's based in Windows. So LSAS is the Local Security Authority Subsystem Service. Say that 14 times fast. Basically, this is where Windows stores your username and password. So let's put ourselves in the mindset of a typical enterprise network. Everyone has their Windows laptop that they sign into every day. It's connected to Active Directory. And there's a bunch of different resources and services they access all the time, right? They browse to a file share, they go to an internal corporate website, and they never have to like re-authenticate once you've signed in once. That's because it's using what's called NTLM authentication, and that's because your credentials are cached. This very complicated looking chart that's hard to read because of the projector basically says that in older versions of Windows, you'll have the actual clear text password just sitting in memory. It is kind of encrypted, but the keys to decrypt it are also sitting in memory, so not that hard to get. In newer versions, including Windows 10, and we'll show this off, I think we'll have time, it's your NTLM hash. The problem is a lot of those NTLM authentications start with the NTLM hash, so you can just do an attack called pass the hash, and you never actually have to know what the clear text is. And if you're just really desperate, an 8-character password stored in the NTLM format, there's no salting going on here, it's just a hash. A couple of GPUs, you can brute force that in a few days. So it's not the greatest hash to be storing things in. So we're an attacker, we're on this network, and say we found a system or a server where we've got domain admin is logged in, and we want to get their password hash. How do we go about doing that? Well, enter a tool called Mimikatz. This is on GitHub if you guys want to play with it, again, on a system that you're authorized to do so. It does all sorts of cool things. We're focused on just this one part. The downside is that it's been around since like 2015, I think. So just about every antivirus or EDR will flag it, eat it, block it, all those good things.
If you download it, Windows Defender will immediately eat it.
Yeah.
So
You can go and like recompile it or try to change it, remove strings from it and such. But it's kind of a lost cause in a modern enterprise that's going to have those EDR or endpoint detection and response tools. So what do we do about this? Well, enter Microsoft sysinternals. Sysinternals is a tool set that Microsoft publishes for system administrators. There's all sorts of different versions or tools rather. ProcDump is one of them. There's like ProcMon, which will let you see running processes. There's all sorts of other debugging features. And this was kind of the solution from them. So instead of running Mimikatz on the system directly, we're just going to create a full memory capture of the LSAS process, write it to a dump file, take it off the system onto a computer we control, and parse that dump file to get that password hash. It's kind of in the bullet points, but the -MA LSAS specifically is a very easy thing that you can signature and pick up on. So this worked for a while. It'll still work on kind of a base system with just like regular antivirus. But this was kind of the next way to dump the LSAS process to get those password hashes. So also side tangent, you can open Task Manager and right click create dump file. That works as well. You do have to be an admin to do all of this though. So we created our dump file here, and then we basically just tell Mimikatz, hey, go ahead and use this dump file instead of the active system memory, and we can get ourselves an NTL and password hash for any of the accounts that have logged into this system since it's the last time it's been rebooted. So we have problems where we're signaturing on the command line. What do we do? Well, let's go one layer deeper. Let's just go call the actual Microsoft API function that this ProcDump tool is calling. So minidump write dump is that actual function, and you pass it some basic information like the process and process ID, what type of dump you're doing, and where you want it to write the file. So pretty simple. We're essentially building the same tool, but because we're compiling it, we can control all those parameters that would normally be in the command line, just hard code them in the tool, recompile it each time we need to do it. Also, we're changing the MD5 hash of the process along the way, so tools that just use hash-based detection to pick up on a piece of malware are going to be blind to this because we've recompiled it, it's now looking different, and we can put all sorts of obfuscation in there if we want to. So one thing to note as well, you do need something called SE debug privileges. This is something that typically only an administrator can request, but it's one of the core privileges in Windows that allows you to do kind of more strange or unique things. This one, SE debug, is to debug processes, hence the memory dumping capability. So what does this actually look like? So this is, you can find this code on the internet, so it's pretty easy to find. You basically start off, and we'll actually look at this in the VM in a second here. You create off by basically grabbing the LSAS process, which is that first part. Well, actually, before we do that, we have to create the dump file that we're writing to. We get our file handle. We then find the LSAS process, which is what that handle snapshot is. And then we try to actually get the handle to get us the PID, or the process ID, of LSAS. And then it's as simple as calling the minidump write dump function, passing the PID of LSAS and its handle, the file we want it to write to, and the fact that we want the full memory to it. So what we've done at this point is removed all those kind of easy indicators. We don't have command line arguments. We don't have a known MD5 hash. We're now putting our own custom tool or binary on the system. So we can actually take a look at this. So I have that code up here in Visual Studio. I've already set this up. You basically just have to add a DLL to your build path, and we're going to hope this lets me click. So we can build our solution. I think it's already built. And let's just clear out the old one. All right, this VM, Windows on a Mac on a projector is not the easiest. But all right, so we're going to run our process capture. right? All it's doing is calling mini dump write dump. We can see LSAS did dump successfully. And if we go back, we have our dump file. It's about 51 megabytes, so between 50 and 100 megabytes is what you're usually looking for. If it's like 0, you know it failed. We're going to take this dump file, and we're going to, just for the sake of the demo, paste it in here. And we'll run Mimikatz. Alrighty, so the first thing we need to do, we talked about that SE debug privilege. Technically, we might not need it, but it's always a good rule of thumb to request it. So we're good there. Now we need to tell Mimikatz that we're using a custom dump file instead of dumping the memory on our own system. So that's the Securlsa module, Sekurlsa, mini dump. So now we're using the dump file instead of using the running system, and then we can say Securlsa. And if we scroll all the way back up, we should see, there we are. So this is my active session on the system, and you can see there my username is user, and that's my NCLM password hash there. So that's the same value as what's being stored in the Active Directory database, and I could use this value to pass the hash and authenticate to a file share or another service that's using NCLM passwords. You'll also notice that there's some other modules that LSAS has, like TS package, wdigest, and Kerberos. In those older versions of Windows, or based on how the system's configured, you may actually see clear text passwords there, which is always wonderful when you're on a pen test, because then you just have their password. So there's a question.
Do you still need SE debug to run the script to get LSAS? So you only need it for...
You need it to
Mimikatz.
create the actual memory dump,
Okay.
yeah. It's one of those.
You do have to request SE debug. So if you're dumping LSAS, even with our custom script, we still obtain SE debug. And SE debug just is what lets you create the dump file.
Yeah, so we can see right now the SE debug privilege is enabled for our session, so this is a cool thing you can check. And like Paul said, you can go and code the requesting of it as well.
Yeah.
That's also one of the defenses against this, is if you have administrators that normally don't need to be dumping process memory, which is pretty common that they wouldn't need to be doing that, you can just revoke this privilege from them and reduce the number of accounts that may have the ability to do this in an enterprise.
One thing I would point out is basically every EDR ever will detect the specific variant of procdump, but this is kind of just like the get your foot in the door, simplest possible custom procdump you can get. This is just what the sysinternals procdump would be doing, but there's a lot of variants on this and a lot of different ways to avoid detection.
So which person does would be like detected with like a base Windows Defender?
I don't know if base, do you have Defender turned off on that?
It is turned off, as in it's going to eat Mimikatz if I turn it on, but I don't think it would mind me running that. It's going to be something like Defender for endpoint or CrowdStrike, maybe some of the other
Because it's not really
tools.
malicious, right? You know, we're kind of using built-in Windows functionality. It's usually malicious, but
So-
I mean, I can't think of a reason where you need to dump
Wait,
But if LSAS crashes, like it makes a dump file, right?
So let's talk through, just because we have a minute here, I do want to get to some just general Q&A as well. One of the things that we're importing is debug help. It's probably hard to see, but debug help is a DLL in Windows. For those of you who haven't used DLLs, it's like a shared library. So I can import the DLL, and then all of its functions are available to me. So if we think through an EDR, let's, I don't know, Silence, for example. It's an EDR. How does it pick up on us calling this function? So what it's actually doing is it's intercepting us loading the debug help DLL, or in some cases NTDLL, which is like the base one before you get to the kernel. It actually is going to insert its own code into that DLL. It says, hey, if anyone ever calls minidump write dump, let me know about it. And then I'll continue the execution along to what it was supposed to do. So that's called like hooking a DLL, and we can do a technique called unhooking to reload that DLL, and sometimes, like in Silence's case, get past those detections. But that's how you might go about detecting something where we're writing our own code and have our own binary, is looking at the DLLs that are loaded, or in some cases, hooking those DLLs.
And unhooking can be as simple as just hey, I actually want to load this DLL from this file here. Like, you don't necessarily have to do anything too complicated. But as far as like detections, a lot of the detections I've seen for more EDRs would be signaturing LSAS, the actual dump file itself, so looking for the MD&P headers within the file being written to disk. So ways around that, you encrypt it in memory, you know. Or an unsigned binary accessing LSAS. Well, you process inject into a signed binary. So it's a constant game of they change something to start detecting a technique. Okay, well, we'll do something else. You know, there's always a way to figure out how to either unhook or subvert what they think we're going to be doing. And it's usually attackers have to get creative and figure out a way around the controls. Yeah.
It's like, how would you know exactly what they're looking for? Like,
You guess, mostly.
yeah. Okay.
Some EDRs you're able to get copies of. It's pretty hard to do. For some reason, they're very protective of the program. And if you're not buying like 100 licenses, they don't really want to sell to you. So it can be hard from an attacker to actually get copies of the software to test against. But they generally have traits in common. Most of them will do some sort of hooking. Like Defender for Endpoint, that operates at the kernel level, so it actually doesn't need to hook into the process. It can do all of its magic within ring 0, which is like highest privilege. So it's mostly a guessing game of, well, we got caught because of this, especially like with purple teaming where we're working collaboratively with the client. Then they'll say, hey, this alert was triggered. Or, okay, well, they're alerting on an unsigned process touching LSAS. Maybe we should inject into a signed process. So it's very much a guessing game, and we keep using a technique until it doesn't work anymore, and then we figure out why it doesn't work, and then try to come up with a way around it.
Have you ever had any luck with self-signing your process?
No, I don't know if self-signatures is really a
Yeah.
thing that anything in Windows pays attention to. For $300, you can buy a code signing cert, but that's pretty expensive for something that could get burned on an engagement. So,
Yeah. You could also just look for like exclusions, like C scripts or software distribution places. Try to enumerate some of those for the tool. But yeah, there's no like magical answer. If there was, then our job would be a lot easier. That's part of the fun too. Is it worth dumping memory on the system? Is it going to get us what we want? And there's other techniques you can use. There's a tool out there called Bloodhound. If you guys want to do some research on that, that like will enumerate an entire network and tell you like here's the key systems that would be like that path to administrator.
Bloodhound is awesome. It will also light your network up. Every IDS in the world will be very scared as to what's happening. There's more like stealthy flags you can use with it, so it's not as ridiculous, but the base Bloodhound, you'll know it's running on your network.
So just a quick note here. We do have some positions open, and then we'll have a general Q&A as well, so we can go back to the topics. So if you would like to intern with us next summer, or you're looking for a full-time job, both of those are open. There's spots both in Minneapolis as well as across the country. We've moved to like a hybrid work model, so if you want to work from home most of the time but just live near a major airport, that works pretty well. But yeah, take a look at those. They're also on SciHire. You can also reach out to us or to Katie, our recruiter, if you have questions, and then try to apply probably before September 23rd for those, and then there's some interviews that go on. So, and if you want more information about that, Cougar 1011 right after this, we'll be talking more about PWC.